Welcome. In this session, we'll be going over automating HCC coding and preparing for RADV audits with Martlet.ai. I'm Hasham. I'm the principal ML engineer, as well as the co-founder and CTO at Martlet.ai. I primarily work on medical coding. I'm also the primary or the principal investigator for government grants like SBIR, and I'm the one leading the technical side at Martlet.ai, where we're building medical coding platform, RADV audit platform, etc. I'll hand it over to Ritwik.
Mhm. Uh, Thank you, Hasham. So, hi everyone. My name is Ritwik. I serve as the senior director here at Johnson Labs, plus also one of the co-founders, along with Hasham at Martlet AI. My focus area has been working on various different payer-related use cases over the past 5 years, like accelerated underwriting, risk adjustment, prior authorization, and much more. So primarily focused on medical for coding for a lot of these use cases. I mainly overlook the GTM side and everything revenue at Martlet AI. Next slide, please. So in this talk, I'll give you a quick overview on what all we'll be actually covering. So we'll be giving you a quick overview of Martlet AI and Johnson Labs, the relation between those two companies, who we help, future-proof risk adjustment using AI, CMS RADV updates for 2025 that have recently come in, then Martlet AI workflows that we actually help with, a public case study that we have established with one of our customers, benchmarking against some of the larger general purpose language models that are out there and some of the open source models that are out there, and then RADV audit defense solution that we'd like to show to the audience here. So Martlet AI is actually a spin-off company out of Johnson Labs. I'll quickly give you a brief of Johnson Labs first. So at Johnson Labs, we had two main offerings at Johnson Labs, which was the medical language models library. Initially, it was called the Healthcare NLP library, where we provided smaller models for various different tasks like entity recognition, entity linking, assertion status, relation extraction, mapping clinical entities to standard terminology codes, and a lot of SLMs also within the libraries that are very task specific. So this, and we also, Hasham, move over to the next slide, please. Then the visual language model library. Initially, it was called the Visual NLP. It has end-to-end capabilities of any OCR solution, plus much more. That's why we kind of rebranded it to this, because you can actually do entity extraction straight from PDFs as well, handwriting detection, signature detection, and much more. Very, very focused on healthcare-related documents. So a table spread across multiple different pages that can be tackled easily with the visual language models library that we have here at Johnson Labs. So now a quick background on Martlet and how we actually came up with it. So Martlet AI actually helps payers and providers bring HCC coding solutions in-house. One of the key things that we were actually noticing, and I'll walk into detail and go into detail on who we actually help. But one of the issues that we were seeing, Hasham and I were seeing over the past couple of years, where a lot of these payers and providers used to come to us, they would try to put these pipelines together using some of the smaller models that we have to bring HCC coding solutions or like risk adjustment solutions in-house, where they wanted their own set of also coding rules attached on top of the engine that they were building. They wanted to reduce vendor dependency. So that was the initial birth of Martlet AI and why we decided that we should actually start working on it, where we come up with a baseline engine that can be customized based on every client's needs. So yeah, so that was the genesis of Martlet AI. So here we, like I said, we focus on solving one of the most critical challenges in the healthcare right now, accurate risk adjustment and HCC coding. We work with 5 key segments of the healthcare ecosystem. Medicare Advantage organizations, where risk adjustment accuracy directly derives reimbursement and compliance. Medicare ACOs in value-based care, where we help improve coding integrity so providers can succeed in shared saving programs, Medicaid MCOs, ensuring appropriate funding by capturing the full clinical picture of high need populations. Then exchange health plans under the ACA, where coding precision reduces audit exposure and stabilizes their plan economics. And finally, providers and health systems, like I mentioned, those were the initial genesis of everything, where we help them bring HCC coding capabilities in-house, which is not a SaaS, can be customized on their own set of coding rules. And it actually helps them protect revenue integrity, reduce a whole bunch of dependency on outsourced coding solutions, manual coding solutions offshore, so they can actually have everything in-house, where our engine does the first pass in-house, and then their manual coders can just do a second pass pair before submitting it to either the payer, and then the payer can be submitting it to the CMS. So what makes Martlet unique is that our HCC engine completely runs within your premises. It has capabilities of even running in an air gap environment. We do not call any kind of external third-party APIs. We have our own trained models. We will be presenting benchmarks for those as well during this session. So in short, whether you are a payer or a provider, our mission is to make risk adjustment more accurate, defensible, and scalable with healthcare-specific NLP models and LLMs that we have trained. Okay, so some updates on CMS announcements on RADV audits this year. This is going to set some context on why we decided to come up with the RADV platform. So in 2025, CMS is taking a much more aggressive stance on RADV audits. For years, RADV was treated as a sample level compliance exercise, but starting with the new rule, CMS has expanded both the volume of the audits and the financial exposure tied to them. So extrapolation is now the standard. If CMS identifies errors in a small audit sample, that error rates gets projected across the entire plan population. So for a large MA plan, this can mean hundreds of millions of dollars in clawback if there are coding errors that are identified. So the focus is no longer just on random audits. CMS is also targeting high impact, high risk conditions such as sepsis, malnutrition, acute respiratory failure, and epilepsy. Just a few examples. So it's very targeted. These are areas where coding is often inconsistent, which has been recognized, and where the financial risk is the greatest. And at the time, CMS is demanding defensible evidence as well with each code that has been submitted. So it is not enough to simply have a code in the record. It must meet the MEAT criteria and should be tied to the correct date of service and come from a credentialed provider. So in other words, documentation integrity is under the microscope like never before. This has created a real challenge for most of the plans, and most of them are usually used to depend on manual audits like PDF-based workflows, and those processes were designed for like a small subset, but now that has expanded widely. So for some of these larger plans, there is no other option than integrating AI within their workflows. Okay, so at Martlet.ai, we work with three separate workflows and where we master. One is suspective coding, retrospective risk adjustment, and RADV audit and defense. Hasham, let's move to the next slide. I'll explain more on using the infographics. So suspective coding, and this is something that we have integrated within multiple large health systems. So And this is where we integrate within the EHR systems, like eClinicalWorks, Epics, and we'll walk you through a public case study as well. So what we are able to do is we are able to analyze the pre-visit data. So like any historic data that has been sitting in the EHR for the appointments that are upcoming the next day or in 2 days, whatever the workflow might be for the plan. So we are able to parse the chronic conditions and show the HCCs at point of care. So it does two things. One, it closes the care gaps. And second, it of course uh, gives the provider the opportunity to uh, treat that condition. And if it's treated correctly within the frameworks, they have the opportunity to code it as well, which affects the top line directly. So this is one use case where we have seen it directly has a high ROI. If you're able to identify more codes, it's not just ROI, but it's more about closing care gaps as well. Now, coming to a post-visit HCC optimization like retrospective reviews. Retrospective reviews is not just about optimization. It's a basic necessity before, and retrospective reviews is a lot of times it's done on the health system level as well, and then it's done on the health plan level as well. Most of it we have seen is done on the health plan level because on the suspective reviews, the codes are usually submitted by the NPs or the providers at point of care, and then the documentation is sent to the payer, and then the payer usually reviews those documentations, comes up with the ICD-10 codes and the HCCs, which is then submitted to the CMS for the downstream reimbursements. So here as well, we are able to ingest patient charts in batches, show it on a nice UI where coders can simply go and accept and reject those predictions. If there's any set of coding rules that that the health plan would like to integrate, we are able to do that as well. Each of those come with each of the extraction come with a confidence score attached to it, plus the evidence as well, which we'll show shortly as well.
Okay.
Okay.
So yeah, I'll take it from here. So thanks, Ritwik. With that explained, we'll go over one case study and then some benchmarks, and then I'll actually show a live demo. So as we already talked about, HCC, retrospective coding, yet prospective coding. So in prospective coding, it makes a lot of sense to actually integrate with the EHRs, right? So we have, in this case, what we usually do is we have the models deployed inside the customer's environment. Data doesn't go out. No external API call is made. We have connectors for nearly all the major EHR providers. We pull data in standard file formats or any other format for that matter. And it's a bad job that runs overnight, and we process all the results, take the delta, show them to the provider the next day. And this is how we're able to integrate and find gaps in coding. One such example is WV Medicine. It's a public case study. Like we have other customers as well, but this is one public case study in which we did this with Epic. So basically, we would first get the historic data of patients that are scheduled for the next day. We would track back. Basically, we would pull their data 3 years back, and we would process them. Then we would find codes, and we would find conditions that were actually never billed. For example, there were some consistent high HbA1cs or something, and that was never coded, or anything for that matter. So we would then find those codes and those conditions and suggest to the provider the next day. Then there's a selection ratio. The provider then looks at it. They can review which historic chart actually had that condition. So they just click on it. It takes them there using a Fire app. And basically, they can just make that decision at that time. And if it makes sense, they can even do recapture or, improve their documentation as well. For this particular health system, this is a reasonably sized health system with 100K total patients. We process roughly about 30K documents every single day. It's a bad job. And basically this way, and yeah, of course, everything that is, every code that is suggested or every condition that is suggested is backed by me and evidence, so that that is all linked. It's not just a single prediction. And this way, we should be able to identify gaps in coding and obviously revenue. In terms of benchmarks, so what do we actually deploy? What the model is actually like? So we have a whole suite of models, including some of the bigger ones, which are the 70B models, and then we have smaller ones. So 70B models, we can compare them easily with the bigger commercial models like ChatGPT, MedPalm, OpenBio, and as you can see, we lead on most of the benchmarks. So these are different benchmarks, like these are different data sets. These are industry standards, by the way, MedQA, PubMedQA, etc. We did our own testing as well in terms of summarization, MCQ selection, etc. And we find similar things. And the reason for that is we have accumulated quite some data over time because we've been doing this for a while, and we can always tune the models much more to a much more granular level so that they're more accurate compared to the other ones, because the other ones are primarily general purpose models, right? And what we usually deploy are these smaller models, starting all the way from 3B to 14B. And even in this case, as you can see, our models, even if you compare the 8B ones, we lead on most of the benchmarks compared to the industry standard, or not industry standard, but the other leading benchmarks on the same data sets. So yeah, as you can see, we can, this is a comprehensive list. So, and these are, by the way, the models that we actually deploy. So because the reason is we also have to keep in mind how big the model could be before there's a cost penalty. So obviously these need some GPUs, but these are smaller models. They don't need an expensive infrastructure to begin with. Which is why in our HCC solution and RADV solution as well, we sometimes even go below 8B to 3B or even 1B, depending on the situation. Yeah, so we have a whole suite of models. To summarize this, basically, the 70B model outperforms MedPalm and other open source models, and even the general purpose commercial models. Yeah, as demonstrated here. Okay, now coming to the actual discussion, which is RADV defense solution. So in addition to the HCC one, we have an RADV defense solution, which is of two types, proactive and reactive. What that entails is, in proactive, you can literally, let's say you have to run your internal mock exercise to see if you are in compliance with CMS, like just to identify how much percentage of overcoding is in your data already before you even submit to CMS. So this is where proactive is, because everything resides inside your environment. You don't need to share data with anyone. You can literally process millions of documents, nearly all the documents that you would submit to CMS, and just run a mock RADV project and see which codes or what is the percentage of false positives, or because what happens in this pipeline is the model would run through all the records that are provided, and it would identify missed ones, as well as, more importantly, the ones that are invalid codes, means they are false positives and don't have enough evidence in the text. That way we prepare for, before you even submit to CMS, this way we can prepare for reduce your chances of clawbacks. The other one is reactive, where you actually get, and this is right now what is happening, you actually get a notification from CMS that certain enrollees, or nearly all enrollees, would be audited. In that case, we have connectors that pull from CMS, the CDAT files. We again do the same exercise, link the codes to evidence, find gaps or find false positives, and the user can go in there and actually make changes, and they would be able to export CMS-ready packets. there's a complete tool for this. I'll just go over. I'll go over the tool now. How does it work? Again, we just ingest audit packets. AI looks and substantiates codes, links them to evidence, granular page level linking, because these are all PDF files. It could be dirty OCR files. Well, I'll just show that in a minute. And we explain the evidence, flag codes, and then again, it's a tool. It's a user in the loop tool. So users can make changes. The first run is done by the model, but users can make changes, and then they just export CMS-ready packets, and they can just submit to CMS. What does the tool look like? So this is actually what the tool looks like. I can just go in here and create a demo, like a project, let's say. I can assign to users, like share it with users, and then just create a. So this is a standard audit packet that you can just export, or you can link it using a batch job. We can link it to other data sources. And the model, by the way, this is a real demo, and the model is running real time. We go in here. Let's say we only had 2 enrollees, and each enrollee had a certain number of files. Let's look at this. So user can just go in there. The first pass is already done by the model. It has identified all the codes. So the input to the model or to this pipeline was PDF files and codes for this specific enrollee. That's it. The model then went over all the codes and all the files and linked them. So for example, this is a wrong code. It says no files are, for this code, there was no evidence in any of the files. For the other ones, the model was able to find evidence, and it would actually tell you that, okay, this file on page 3 has evidence. So, it's HB1C is high, etc. All of these files are actually, again, the type of file doesn't really matter as long as it's legible. We OCR and we do all that kind of stuff. It's able to handle really large files as well. For example, like this, it would directly take you like here, right? So this is a redacted file, but we're able to do this. And user can make changes as well, by the way. So for example, they're like, oh, maybe they found a code, maybe they think that this code is valid and they found it in, let's say, this file or something. Then they're like, okay, I found it on page 1. I don't know, evidence for code, and they can just add evidence, and it just gets linked over here. On the left side as well, it would tell you which codes are linked to which files, right? So it would tell you that. And once you're done with your, with this, and you can, again, unlink it, all that kind of stuff. You can just submit it, and it gets submitted. Over here, once we go here, you can see that it's now completed. Once you're done with all the tasks, and you go into export, over here, it would tell you how many documents were uploaded, but out of those documents, which ones were valid documents or had valid codes, how many codes in total were valid out of the ones submitted, what was the payment year, how many enrollees, et cetera, and I can just download this packet, and it would be a CMS-ready packet with complete audit trail, chain of custody, logging, and the general rules of CMS, which includes 2x. So for each code, you can have max 2x. PDF files, etc. All of that is already implemented. But yeah, this is essentially it. So it's a user workflow. Users can, again, the first pass is done by the models. Users can just go in here and make their changes, and once they're done and they're confident, then they can just submit. So yeah, that's essentially it. Thanks for joining in.
Yep. Thank you.